And let me share my screen. So if you are enrolled in the next batch, which is the LWC training, send me a message so that I can add you to the different WhatsApp group. If you are planning to join that LWC, we did a demo session today. We are going to do another demo session from the instructor, and he will basically you will learn about him. If you think he's going to be good, then it's if you have any questions regarding the training, you can ask him tomorrow. It is around 9 a.m. Central, and um, if you have any questions from this training, feel free to reach out to me. If you want me to cover any topics that I missed, or you think that, okay, I would need some additional help, don't hesitate. I'm here for you. So if you just need any more hands holding, don't hesitate to reach out. Okay. So today we're going to go ahead and talk about the test classes. Okay, so what are test classes and why are those very, very important? So we need to test the code, right? If you have put any code in production, you cannot just go ahead and put code in production because it can break existing functionality. So generally we used to have QA team, which is responsible for testing those different scenarios, testing the new changes that we are planning to deploy to production. So now what we have, Salesforce basically introduced this concept of test classes where you also as a developer have to write the test classes to test your code, and the code coverage that it expects you, it is minimum of 75%, but a lot of companies code coverage goes up to 85, 90, all over the place. Okay. So why Apex test class exists. Now, Salesforce enforces automated testing because your code is running in a multi-tenant environment. When I say multi-tenant, basically there are different companies or orgs which are using your resources, your memory, your instances, all of that. Deployments that you're going to be doing into production should be safe and also should be predictable. Means it should not fail anything that's already working. It should not break any code in production. So tests basically are required to push code from deployment to production. But not that's not always the case. A lot of companies have these rules that, okay, from developer org, if you are pushing to test org, you require test coverage. Even from some don't want it from dev to test, but they want the test coverage from test to QA. So when the code goes from test to QA, they need to have code coverage so that they are not waiting the last minute into production to have the code coverage. Okay, so it depends on the company policies. It depends on their deployment team because they can set up those rules that, okay, we want the code coverage after test org. But if your company is not following any of their own policy, according to Salesforce, the code coverage should be there when you're pushing anything to production. Okay. So you have to write test classes for every Apex class that you have written. And every test class should have methods. Now, what are those methods should test? Okay. So there is a possibility that you can access your org data. Okay, so in Apex, there is an annotation. Does anybody know what the name of the annotation is, which allows you to access the org data?
True.
True?
Is that see all data true?
Exactly. Very good. So that is the see all data. Now, what does this basically annotation tells you that, okay, you can access your org's data. Now, is it a good practice of having see all data to true, or is it a bad practice? What do you think?
It's a bad practice
Excellent. It's a bad practice. Now, why do you think it's a bad practice?
because you basically have, instead of using the fake data, you're using the real data to test.
Okay. So then what will happen if you're using the real org data?
You can manipulate data and you can just Um,
You can
uh,
inadvertently change data that would make
So
the
the problem
live forge fault.
Yes, the problem with this is, let's say your test classes passed in one org, okay, because it had the data that you were expecting and it passed. But if you push your code to another org, that might not have the data that you want. So your test classes will start to fail. But when you're not dependent on your org data, you have your own set of test data that you are creating, then what you have to do is you don't have to worry about it, and you're basically the if you go from one org to the other, your test cases will not fail. So see all data is not a good practice. It allows you to gain access to the org's data, but it's not a good practice, because if your test classes are running successfully in one org, they might fail in your next org. Okay. A good test must prove behavior, not just the line coverage, right? So when you are writing test methods, you just not have to write code to cover your code. You actually have to make sure that your code is working as expected. You have to use assert statements. A lot of time people have covered the code by invoking the method and all that, but they never have assert statements to actually test if the value is correct or not. Okay. So not just the line coverage, you also have to test the behavior. So your test should validate data is created, updated, deleted correctly. So you should, if you are doing something like that, you should validate all of that. You should make sure that business rules are being enforced if you have wanted those, and if errors are being thrown when it is supposed to. You should check for exceptions being thrown. Edge cases needs to be covered, and also your code should not only work for one record. You should make sure that your code runs for multiple set of records. So you to have to check for bulk records as well. And callouts should return expected outputs. So if you are making a call to an external system, you cannot make a call out from test classes. So you need to have a mock class. Mock is basically creating a response. Okay, a mock response. Because can you do callouts from test classes? No. So how will you test if the callout is working as expected? So what you'll do is, in that scenario, you will create a mockup class. That mockup class basically mocks the response of your callout, and that is how you will do the code coverage, because Salesforce does not allow callouts to be made to external system via test classes. Okay. Now, whenever you're writing test methods, you will be using certain methods from the system class. Assert, system.assert. So system.assert basically checks, system.assert basically checks, sorry, not system, system.of_assert. So this is one method that is available, assert statement. It checks, does this value, the first parameter, is it true or not? If this parameter is true, it will be fine. If this parameter returned out to be false, it will display the message that you have put it in the next argument. Okay. System.assert equals basically checks if the two parameters are equal or not. So here it would be system.assert equals. Okay, and it will basically have two parameters, A, B. A, let's say, is called as expected value. B is actual value, and it will check is A equals to B. And if it is equal, the test will pass. If it doesn't equal, it will throw the error message that you have written after A, comma B. Okay, once we do some examples, you will understand. So this is to test if your test class's output is working as expected or not. Covering the code coverage is the easier part, but actually testing your code is basically running the code with the different methods and making sure it is giving you the right results. And then assert not equals means to check those two values are not equal. Here it is checking for values to be equal. Here it is checking values to not to be equal. Okay. Any questions, guys? Are we good? Everybody following?
yes, I'm fine.
Okay. Rafini, Linda, who else is there?
Yeah. Yep,
Okay,
I'm good.
good. Okay. So then the Apex test execution environment, it is very, very important. Test always run in an isolated context. Okay. By default, the test cannot access your real org data until or unless you're using the annotation on the test class called see all data. Okay. So that's why they say whenever you're writing test classes to create your own data. And this way it is basically you can test your code multiple times and it's reliable. Now, always they have said to avoid the see all data. If you have set is test see all data to true, tests become dependent on existing org records. Test will break when the org data will change and deployments will become unstable. Okay, so it is very important not to use see all data, but in cases there might be where they are just quickly checking if the code is working as fine. So for those reasons, they might do that, but generally it's not recommended. You only use it in rare cases like testing certain standard objects or features that requires org data. Only in those cases, you will use something called as see all data. Now, governor limits in test classes. Now, the test methods also run with the same governor limits as normal Apex, but Salesforce gives you this tool called test.of_start test. There is a tool called test.of_start test and test.of_stop test. So when you basically write your statement inside of these two things, then a new set of governor limits is given to you. So it's always important that whenever you're writing a test method, you should always have a test.start test and a test.stop test. Basically, this will give you the resets the governor limits for the code inside that and also forces making sure now async code will run any time, right? You cannot predict when an async code will run. It can run at any whenever resources are available. But when you have written the code inside of start and stop, it makes sure that the async code also completes before it hits the stop test. So you can verify that your code has run successfully and then you can test it. Okay, I'll repeat here. So let's say you have a queuable job that you are executing. Now that queuable job is a asynchronous job, right? It's not something that happens right away. It happens asynchronously, means behind the scene, you cannot know when will it happen. But when you're calling this queuable job from this start and stop, then it makes sure that before it hits the stop, that queuable has run. That way, you can use assert statements to validate if it is working as expected or not. So stop test.stop makes sure that queuable is executed. Okay. So how will you do to, yeah, go ahead.
Can you explain that again?
So, okay. So let's say you have a queuable job. Okay. Queuable job was to send a queuable job was to make a call out. Okay. And then come back and update the record. That was the queuable job. Okay. So from the Apex test class, you will be invoking this queuable job, or it might be possible that the method you are invoking indirectly invokes the queuable job. Once that queuable job gets queued, you cannot tell a queuable job to run it at a particular time, right? It will run when the resources are available. But if you are using test.of_start and test.of_stop, it basically makes sure that your queuable job will run before it hits this test.stop. That way, whatever this queuable job is supposed to do, you can test that did it perform that action or not. If you don't use these, then you don't predict when this queuable will run. Okay, so it might be possible that you had system.assert statements, but the queuable job has not run yet, so your assert statements will fail. So it is important to use start and stop to make sure queuable finishes up before it goes any further than stop test. Does it make sense?
Yeah, so basically we gives it a timeline between start and stop.
It will execute, correct. It will make sure to execute. Okay? So the correct pattern when you are writing a test class is arranging. First of all, you will be creating test data. Then you will be using the start test. And then you will be using the actual method that you have to test. You will call those methods, invoke those, and then you will have stop test. And after the stop test, you will use the assert statements to verify. This should be the order of your test class. Okay, of your test method. Okay, so in the test class, the first important thing is setting up the test data. Okay, so you will basically annotate with the annotation called @test_setup, which basically tells you that this method is to setting up the data. Now, there are a couple of frameworks that you can follow. You have the option, you have multiple options. You have first option is you create the test data in every class. Okay, that is in every class, you create a method at the top, which is responsible for creating the test data. Okay, second option is within every method of the test class, you create test data for every method. Okay, and then the third option is you have a separate class which is called like a test factory, and it is responsible for creating test data. And all you do inside of your test classes is basically call these test factory and get those records. Okay, so which out of the three, thinking at this option, which do you think is the better option?
In
Think
test factory,
Test factory, yeah.
Excellent. And why do you think test factory is the better option?
because it's kind of separate from the main class. So
Okay, and what benefits will it offer when you have it in the separate class?
we can it's easier to just carry it to the other orgs if we want to test it within multiple orgs.
It can be used with every class.
Exactly, it could be used with the individual classes. Yeah, it can be used. And the other benefit is, guys, your test can now focus on basically the actual business logic to test. And it will reduce the size of your test class, because if you are, this is not a good option anyway, right? Within every test method, because see, it is going to increase the size of the class, and then first you are creating the test data, then you're invoking it. This is not a good practice at all. Some businesses use this approach where in one class they will have a test setup method where they're setting up the data, but that's also not a good way, because you're duplicating this code in every test class, right? If let's say in every test class you need 5 accounts, 5 opportunities, 5 cases, you're creating that test setup in every class. So in test factory, what happens is it basically have a separate class, and that separate class is responsible for preparing the test data. And it's inside of your test class, all you're doing is invoking the methods of this test factory, which is actually creating the test data. So this is the better approach. Okay. Any questions? Excuse me.
So for test factory, we have some kind of a separate class that
Exactly.
we use that. Okay.
Yeah, in the test factory, they will have separate methods like create opportunities, create accounts with annual revenue 100,000. So those methods, whichever accounts you want, it will give you those records.
Okay. Sounds good.
Okay. Now, the next one is the test setup here. So, whenever you have to write the code, you always have to have happy scenarios to be covered, not just So you have to cover happy scenarios, means is the code working as expected? Then you have to test it with null checks you have to do. Is it throwing any exception, blank values, all of that? Then you have to do it with bulkify records, means more than one record. Then you also need to check some edge cases. If this condition happens, how your code is reacting. Okay. So you have to check different scenarios whenever you're writing a test class. This test setup, basically, as I mentioned, this method runs once per test class and inserts shared baseline data. So basically, it will run once and it will create the test data for you. And the data that you create inside of test setup will be available to all the test method. And you can insert additional data within those test methods also. It doesn't mean that in test setup you have created the data and you cannot create anywhere else. You can still create additional records inside of your test method, but test setup data will be available to all the methods of the test class. Okay. Now, test data strategies. So a simple test create records inside each method. That is one way. When the test is small, when you have to only have 1-2 records need, you will go ahead and use this approach. The second approach is you have test setup, means there is a separate method. You create the base records in test setup, and then in your test methods, you are querying those. And then the last approach we have is the test data factory, and it is the best approach where you will have a separate class which is responsible for creating many records, and you can reuse the same methods in different test classes. Okay, now let's go ahead and do an example to illustrate how to write a test class. So I'll go over to login, and here let's go to this, click on no. And here I'm creating a class called discount service. So we go here, developer console. File, new Apex class, discount service. Now, somebody needs to tell me what are we doing in this class? Okay. So this is the class. Okay. So this class is have a what do you call inner class called discount exception. So it is, we are creating a custom exception. Okay. Because this extends from the exception class, that means we are creating a exception. We are extending from the exception. So that is a custom exception. And then you have a method called apply discount. It takes in 2 parameters. One is amount, the other one is percent. Okay. And then you're checking what is the value of the amount. If the amount value is null, means you are not passing anything, then amount will be considered as 0. And if the percentage is also not passed, it has been passed a null value, then percent default will become 0. Otherwise, whatever you have passed, that will be considered. If the percentage is either less than 0 or it is greater than 100, then you are throwing an exception. Okay. And this is the message that will be added in that exception. So whoever is calling this method, whoever is invoking it, has to handle an exception, because this code can result into an exception. If everything looks good, if the percentage is not greater than 100 and it is not less than 0, you're basically doing amount multiplied by PCT, which is your percentage, divided by 100. And the final amount after the discount is amount minus discount. Okay. Any questions on this so far?
No.
Okay. So now here, if I go to the, how will I invoke this? Apply discount method. How will I invoke it?
Um,
How will you invoke it? What kind of method is it?
Discount service dot apply discount. It's a static.
Very good. And then I will pass in, let's say amount is 1,000 and 20 is the percent. And now here system dot of debug amount after discount. So what's going to be the output in this case?
Amount minus discount. Okay, so it's 100. It's gonna be 2,000.
Okay, guys, what are we doing here?
Oh, no. We're gonna get an error.
Why do you get an error?
So we have, okay, so the first one is amount. No, we're not gonna. So the amount,
Hold on, Mehdi, hold on. Everybody gives me an answer in the messages. What's going to be the output of this program? Excellent. Very good. Okay. Mehdi, what's your answer? I only see two answers, 3, 4, 5. Okay, good. So everybody got it right. Okay, so it's going to be 800. Wait a minute, what happened? Uh, 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 uh. Oops. Okay, so you can see here it is 800. Now, in this case, if I go ahead and debug this and I pass 120, what will happen in this case?
throws an error.
Not an error, an exception.
Exception.
Okay, and the message that it'll throw would be this message, discount percent must be between 0 and 100. Now, right now, this particular code, if this is how you execute. So now you have to write the code coverage, the test class for it. So right now, if you go and you look under the test, you will see that discount service has 0% code coverage and 0 lines are covered. You see this on the overall code coverage. You see this where it says percent is 0 and lines is 0, means none of the code has been covered. Okay, so what we're going to do is we're going to create a new class, which is a test class. Okay, so how will I create a test class? Very simple. The test class needs to be private. Okay, it is, so we will go ahead and discount service test is the name. Okay, and we'll create file new apex class. This is your test class. Click OK. And then let's just copy the code here at is test. So tell me, before I look at the code, what all scenarios you will be testing for this code, for this class. Everybody lists down the scenarios. What all parameters you're going to test with? Based on this, what are the parameters?
Less than 0.
Very good.
When discount is less than 0, discount is more than 100.
Very good.
Between 0 and 100.
Very good. Anything else?
The amount should
What
be,
Yeah,
amount should be something
amount also.
above 0. Yeah.
Amount to
amount
be
is
null,
null.
percent to be null, correct?
Yeah.
Excellent. So you are coming up with, these are the scenarios you have to test it. So you have to write test cases for those. So one scenario would be you giving right values for amount and percent, like 1,020, which doesn't throw it. That's a happy path. The second one would be you will put the percentage as less than 0, or you will put a percentage as greater than 100, like 120, and you are expecting an exception to be thrown. And then you will be passing the null values for the amount and percentage. So now let's go ahead and look at all the different test cases that we have created. So whenever you're creating a test class, you will annotate it with the annotation @isTest, which basically that tells you that it's a test class. and it's going to be private, and these are the methods. Okay, one is happy path, one is null handling, the other one is throws exception. So these are the three tests that you have written. So in the case of happy path, you are setting up now I could have, so in this case, you have amount is 200%. So this will give you the proper discount. So it will give you, what will be the output here in this case? 190, right? 10% discount on 200. So 10% discount on 200,
180.
180. Okay, so that's going to give you 180. Now here, the result. So this assert equals is checking, does the final amount is 180 or not? So this is your expected output, this is your actual output. If both of them are equal, your test method will pass. If those are not equal, then the test method will fail and you will get this error message. Okay? Then the second test is basically looking for null handling. So you are passing a null value for amount and you are giving a percentage of 10. In the second one, you're passing 100 as the amount and you are using percent as null. And in the third, both are null. So these are three results you are getting. And then you will be using assert equals to check what is going to be the actual result versus the expected results. So in this case, you are expecting the amount is 0, 10% on 0 is 0. So it will be 0, result 1. So you're checking, is this equal? If it is equal, your test will pass. Otherwise, this is the message it will throw and your test method will fail. Similarly, like even if one assert fails, the whole test method will fail. Okay? And in the last one, it is checking for throws exception. Now, here you pay attention. System.assert. So can anybody explain to me what's happening in this line? So assert equals and not equals is pretty simple, right? It checks, is the first two parameters equal? If the first two parameters are equal, the test method passes. If the first two parameters are not equal, then you will get a test method will fail and the message will be thrown. Now, what is this doing? System.assert. So system.assert, yeah, go ahead.
So it happens when the discount, maybe discount is higher than the amount, something like that.
Okay, anybody else? So system.assert is what it does. Remember, I told you in the very beginning, what does the system.assert does?
So it checks the main value, the expected value versus the real value.
Okay, in the assert, where is the expected and the real value? There's only two parameters.
So for this one, if what we expect doesn't happen, it throws an error.
So what are we expecting here?
That the discount applies to the amount.
No.
We are expecting the exception to be thrown.
So what does the system.assert does? So basically, system.assert, when you just write system.assert, it basically checks if this value is true, if this condition is true or not. Here, you're explicitly setting up the condition to be false. That means the moment the line hits this, ideally, this should throw an exception, right? This code should throw an exception. So ideally, it should directly go from here to here, correct? This line should not get executed. So if your code is not, if your code was supposed to throw an exception and it did not throw an exception, it will come to this line. Moment it comes to this line, the test will fail because this assert will fail. The moment this assert fails, your test method will fail. Are you getting my point? So you don't want this line to get executed. And the only case this line will not get executed if your code throws an exception, apply discount, and that is what you're testing, right? At this point, you're testing, is my code throwing an exception? In this case, what should happen? This is your amount. This is your percent. So amount is 100, percent is 150. As per the code, anything greater than 100 should throw an exception. What is the type of exception? Discount. So the code will come directly over here. So when you explicitly, and if this code did not throw an exception, then what will happen? This line will get executed. And the moment this line get executed, your test method will fail. Did you understand the meaning of assert?
Yes. So we want to check the
Exception.
exception, not happy path, not happy path.
Not happy. We're checking for exception.
Yeah.
Okay. Did everybody understood, guys?
So first parameter, why are we giving false?
That's how you want. Because system.assert basically checks if the first parameter is true. That's the job of system. We want the test to fail if the exception is not thrown, right? When will you call this? Okay, tell me, when will you call this method to, when will you say that, okay, this particular code didn't work as expected? You will basically fail this test method if the exception was not thrown in this scenario, correct? You want an exception to be thrown. And if
Yes.
it didn't throw the exception, you want to know somehow that the exception was not thrown. How will you know? By explicitly failing the test. So this is the line where it explicitly you're telling to fail the test if this line gets executed. The moment code comes here, that means something went wrong. Are you getting my point? It's a little tricky.
Okay. So by system.assert, we are telling that test is failed.
Failing, exactly. Because only in what scenario you will come to this line? If this piece of code didn't throw the exception, if this, as per our code, if it threw the exception, this line will never get executed because the code will directly come from this try and it will come to this catch. If the code is coming to this line, it means that this code did not throw the exception. It was supposed to throw the exception. It didn't throw the exception. That means something was wrong with our code. So that's why you have to fail your test. And this is explicitly telling your test method to fail.
Okay.
Get it?
Got it. Yeah.
Okay. Now, this is how you run it. So we will go to the test, new run, select your class, and select the methods you want to execute and click on run. And then it will show you all the methods inside of this that it has executed successfully. Okay, happy path, all of them. And you will also see that the discount service has a 100% code coverage. And when you double click on it, you will see all the lines which are blue lines, okay, which are blue lines are covered and your complete code has been executed. Are you getting my point?
Yes.
Okay, excellent. Now let's go to the next example. Now we have another class called account DML service. Okay, so here we will go over and file, close all, file, new Apex class, account DML service, click OK. And over here, I'm going to okay. So what are we doing in here? So inside of this, we are creating an exception, custom exception called account service exception. And here you have a method called create accounts, and it takes in the names of the list of string, okay? Account names. It takes in the name. And if the names you are passing is a null or is an empty list, it is going to throw an exception. Otherwise, it is basically iterating over those names one by one, checking if it is blank. If it is blank, again, it will throw an exception. If it is not blank, it is adding it to this empty list here that you created on the top. And then you're doing an insert on this list. Okay, so basically, all this code is doing is inserting account records, multiple account records. Then what we are doing, mark as customer, it takes in the account IDs, a set of account IDs, checks if the account IDs is null or empty, then it will throw an exception. Otherwise, it will query all those accounts, the ID and the type of those accounts where the IDs is whichever IDs set you have passed. And if it is empty, if there is no records retrieved with those account IDs, then again an exception is thrown. Otherwise, you're iterating over all these accounts and you're updating the type as customer. I believe there is no type, it's customer / direct. That is an actual type. So if you go over to an account record, so if I go to an account, and if you go to this particular account, and if you go to a detail, and you go to a type here, you can see customer is not an option. Either it is prospect, customer direct, customer channel. So these are the values. So there are two methods that are available. One method creates the bunch of account records, and the other method updates the type of those account records to customer direct. Any questions up here?
Can you explain the second part? I didn't understand.
Okay, tell me what's going on. Tell me what's going on. So you explain to me what's going on in mark as customer. What is this doing?
So we have a method mark as customer with which
Which
the
takes in what?
parameters are set of account IDs.
Very good.
And then if it checks if the account is not null or is not empty, sorry, if it's empty or null, it throws an error.
Very good.
And then we have a list of accounts based on that account IDs, which queries the account, which queries the account that has that account IDs.
Exactly. So you're making a query to the account table with those IDs that you have passed in.
Right. And
Okay.
then if the account is empty, it throws an error. If no account is found,
Exactly.
it throws an error.
Very good.
Otherwise, we have a for loop that loops through all the accounts.
Which accounts?
The accounts that's found.
Exactly.
On
These
the
are
list.
just
On the
those-
list. The
yeah.
list of accounts, yes.
Yeah.
And then assign the type.
Okay. And then it is doing an update at the end.
Okay.
Simple?
Yeah, simple. Okay.
Okay. So what will all the test methods you will be writing for this test class? There are two methods, two things you're testing, right? One is
Account is empty or not. There's an account.
no, there are two methods you're testing: create accounts, and the other one you're testing is marked as customer. Okay, so here first you need to check with empty values, then you will pass in the list of string, then you will see if the accounts got created or not. That is the two test cases you will write. Similarly, you will pass in the IDs of those accounts that you just created up there. Then you are basically checking the type of those customers, the type of those accounts, was it customer direct or not? And then and also one time you will pass blank account IDs. Are you following me, all the test methods that you have to write?
Yes.
What about others? I only hear one person talking.
Yeah.
Linda,
Yeah.
Sophie.
Mhm.
Okay, excellent. Now we will go over here and we will go to so this includes happy path for insert, happy path for there, and then here negative test to check the blank inputs, all of that. So here I'm going to create an account DML service test. So we'll go over here, file, new, Apex class, account DML service test. And then this is it's very simple. Test classes is not a difficult thing to write. But when you have a lot of code, you have to write those test cases and it becomes a pain. Okay. Okay, guys. So now one is the happy path, right? So this is a happy insert records. Then it is checking for the blank values. It is testing the create method. Then it is checking the mark as customer method, the happy path, updating the type, and then the negative path. That's it. Those are the 4 methods it has written. So in the first one, it takes in a list of names, okay? Acme, GlobalX, and Intitech. These are the names. And then it is calling the create accounts, which is nothing but this method. So when it calls this method, what should happen? 3 account records should get created, correct? Right?
Yeah.
Yes.
Then you are doing an assert statement, assert equals, checking were 3 account got created or not. If it did, then it is going to go ahead and give you the insert size. What is the inserted size? 3. So 3 is equals to 3 means the test will pass. Then it is checking the does it generated an ID for those accounts or not. So it is checking the first record inserted 0.id. Is the ID equals to null? Means it shouldn't be equal to null. So it's assert not equals. So this will also pass. Okay. Any questions up till this point?
No.
Okay.
No.
Then then again, what it is doing is it is generating a set of the IDs. And in that set, basically, the records that you inserted, you combined all the IDs of those records and put it into this set. Set is called IDs. Okay. And then again, it is checking. It is just testing more stuff. Then again, it is retrieving those names of account based on those IDs. And it is checking, did we retrieve 3 names? Yes, we did. So it is checking, does this list return you 3? If it does, then the assert equals is valid. And then it is checking, is the first name Acme, the second is Globex, and third is Initech, which basically is the same as this one. So it is checking, did those records got inserted successfully with the right name or not? Okay. You don't have to do this kind of testing, but since with the other code, it would have tested it anyways. Again, here you're checking, you passed in a list, but the second parameter is blank. When the second parameter is blank, what should happen? An exception should be thrown, correct? So in this case, if this create accounts code gets executed with this list, with the list which has an empty value, this will throw an exception. So the code will come here. If the code came here, that means exception was not thrown, and that means the test case failed. Okay? Any questions, guys?
So if the last name is empty, it should throw an error. Is that correct?
No, we're not inserting contact. We're inserting an account object.
For the last name, right? Like the account, that's
Name.
whatever the names, yes. If
Name.
the name is empty, it should throw an error.
Yeah, that's what we wrote here. See here? If you go to this, if the name, this one, account name, if it is blank, then throw an exception. And the exception it is throwing is account service exception.
Okay.
So it is throwing an account service exception. So if this code should throw an exception, correct? If
Right.
it is throwing an exception, means it is working as expected. But if it didn't throw the exception, then this line will get executed and this will fail our test. Okay?
Right. Okay. It should throw an exception. If it doesn't, it means that the test is failed.
Exactly. Exactly.
Okay.
Okay? Then here it is expecting, because see, either you insert all records or you don't insert one record, because you're not doing a database.insert. Remember the difference between database insert and a regular insert?
The partial success.
Very good. Very good. So here, none of the records will get inserted. And if the count of good names is 0 and this 0 means the code will work fine. The assertion is passed. The test method passes. Then the next one, it is checking the mark as customer method. Now, somebody tells me what we are doing here.
So first of all, we we list the accounts. We create two accounts.
Exactly. We're creating two accounts.
And
One
insert
is
it.
type test 1 and the other one is type test 2.
Test.
Okay.
Yes.
Then we are creating the IDs of these newly created accounts. We got the IDs, right? Because once you insert it, you will generate an ID. ID gets generated when the account gets inserted. So we created a set using those accounts of 0.id means the ID of the first account, then the ID of the second. Okay. So it created a set of IDs. And then we are calling this mark as customer. Now, what this mark as customer will do, it will update the type of these two accounts to customer direct, right?
Right.
So if you go ahead and query the type of these two accounts after this code has executed, the type should be customer direct. That's all we are testing. Plain and simple. Assert statement equals customer. This should be customer direct because otherwise it will fail. And here it should say customer direct because the actual value is customer direct, not customer. Now
And you can, sorry, you can use list instead of set there too, right? Or do we have to use set here to avoid
where?
If you scroll up, yeah, 81.
Now in this case, you can use list also, but for IDs, generally they say set because it will always give. What is the difference between a list and a set?
The duplicate,
Is not there in a list, in a set, correct?
right?
So this is better to have unique set of IDs.
Okay.
Okay. Now the next one is if you pass in empty IDs, then exception should be thrown. So same way, this throws exception. So if you're passing an empty list here, you can see here you're passing an empty list. In this case, this code should throw an exception. If your code is not throwing an exception, means something wrong with your code. So system.assert to fail the test method. Okay. I hope I'm not going too fast.
No, that makes sense. That makes sense.
Okay. Everybody else?
Yes, Deepika.
Yeah.
Okay.
Getting.
Then you have is not found throws exception. So what are we doing here? This one is you are passing in one account, you're creating one account and then you're deleting it right away. Okay. Means that account no longer exists. That ID no longer exists. So this ID that you're trying to send doesn't exist in your system. So this code will again throw an exception. And if it doesn't throw an exception means something is wrong with your code. So it tried to basically throw which part of this code it will throw. This is the one. So where the ID was not present. So here, if the IDs is, okay, this one. If the account is empty, then no account found for provided IDs. This message will be thrown in this case. Okay, and it is checking, did the message that was thrown, does it contains no accounts found? And if it does, we are good. If the exception was not thrown, then that means something is wrong with the code. Any questions, guys?
So the last part we test if that account exists or not.
No, we are checking that ID if the account doesn't exist in the org. Correct. So
Okay.
you're passing an ID which doesn't have an account associated with it because you inserted an account and right away you deleted the account.
Right.
Even
So
though
we
you have
we
the
have an
ID,
ID,
but
but
that
there is no
ID doesn't
account.
exist.
Okay, gotcha. Okay.
That ID is there because you got the ID in the beginning. So you have the ID, but that ID doesn't map to any account.
Count, right. Okay.
In that case, it should throw an exception. So it is going to throw. Now, if I test this, due to test new run, account DML, all these methods, click on run. So here, okay, failed. So how did it fail? This says update failed. Field custom validation, select an SLA tier for the customer. Okay, so I need to put SLA tier for the customer at line number updates happy path. So I think I need to set up. Oh, so here it is going to create accounts, throw new, add this. Update failed. First exception on row with the ID. This field custom validation exception SLA tier for the customer. So you have to provide the SLA tier for this customer as well. So here, if I go, name is this. Oh, mark as customer, sorry. Did anybody explain to me what happened?
Deepika, there must be some validation. Maybe
Yeah,
if
yeah,
we
yeah.
are
So that's the one. This is the one.
changing the customer direct and
SLA tier equals to, what should be the SLA tier? There is a validation, and I know what the validation is. SLA tier. Okay, platinum. Let's put platinum in here. There is a validation, so platinum. We go ahead and put this in here. Okay. So now I can do this test rerun. It will throw an error again because I think there is another. I need to do that. Okay, so again an error thrown. This time it gives you a better response and it says region. So we will put a region in here too. Like, okay, test run. We'll give a region as well. Is north. And similarly, I will copy this and put it over here. Okay. So now, because moment you put a type in there, like when then that becomes, so now test rerun. So now you have, so it ran successfully. You can see all the methods passed. And then if you go here, account DML, we have 95% code coverage. So every line was covered except one line, which is okay, but 95 is a good. Okay. Any questions?
I have a question. That's a general question. When we write tests and if a test fails, how can we troubleshoot that? Like the way you troubleshoot is one way, but is there any other tips for troubleshooting the test, especially when we have a large or long
So
test?
one of the ways is these messages that you see, this will help you that which test method failed and what was the condition. So if you go to the these ones, right? Expected exception was not thrown, or whichever, whenever you're using the assert statements, that assert statements will tell you what is the exact failure point. And also it gives you the line number as well. So if you see here, it tells me when you went over to this, it tells me that, okay, this line, DML exception failed. It gives me the line number as well, customer DML service line 43. So it tells you where exactly the problem is. So the error message will give you more description and you will be able to fix it. So this error message is the only place. The stack trace is another place that you will look at.
Gotcha. And when we write test cases, what is the best what is the best scenario to do that? It's just so we check the test, we check the class, Apex class, and based on that, we come up with some scenarios and then
Yeah,
based on
because
those
you have to look at them. Each method needs to be covered.
okay.
So you see what that method is doing, what that method is expecting. You pass that method, you pass those parameters to the method, and then at the end, you will check, is the method giving you the expected output or not? Let's say your method is a simple one, converts a decimal, a Celsius to a Fahrenheit. It is taking a parameter as a Celsius. So you will invoke the method, passing a parameter, and then that method returns you back a Fahrenheit value. So you will basically check, is the Fahrenheit value that it returned is matching to the actual value that I expected? And if it is, you will, so every test method needs to be tested.
Right. Okay. So
Then you don't have to write all the scenarios for every test method, but it's a good practice. But then you're just increase, if you test for every scenario, now within the same test method, I can give you 3 scenarios. Hey, give a 0 value for Celsius, give a minus value for a Celsius, give a positive value, give a negative. You can go on and on with different scenarios. It is a good practice, but it can become very long. Your test class can become very long. So if you have at least tested all the happy paths for each of the method, at least you will get the good code coverage.
right. So first of all, we check all the methods. They
Yes, you
all
have to
need to get covered, and
yes,
at least we need the happy
happy
path
path
for each
and
of
a
them.
negative path, to be honest.
Okay. So the happy path is the minimum, but the best practice to
Yes.
have the
Have the edge cases covered, bulkify, all of that. Okay.
Okay, thanks.
Now, guys, there is one last thing I wanted to cover before we wrap up. It is so test classes are pretty much the same. Now, when you are testing integrations, how will you do that? Because ideally, you cannot. Do you want me to cover it today or do you want me to cover it tomorrow?
So if we can cover the whole integration, that would be great. The testing, because I know it's a little bit long.
No, it's not that long because all I have here. Okay, let's do this tomorrow. It'll be an extra class. That's okay. Is everybody okay with that?
Yeah, that would be great.
I have a XML DML service system. It will be a short class because I'll try to explain it, but let's do it tomorrow. Okay? I'll see you guys. If
That-
you yeah, go ahead.
I was going to say for is there something kind of the web component set for tomorrow? You said that
Oh,
9
the
a.m.
webcam. I wanted you guys to practice it.
Oh, okay. Okay.
Okay.
But there was something scheduled for 9 a.m. That's for the weekend.
No, that's for the weekend, 9 a.m. Central. This is
Okay, yeah.
9 p.m. 9 a.m. Central in the morning. That's a demo. Linda, you have already enrolled. You don't have to worry about. So people who have not enrolled, it is
Okay.
just a way to get an interaction with the instructor and get to know him, ask him questions, see if he's the right fit for you for the training. So pretty much to know about that instructor. That's what the demo session is, but not everybody has to attend it.
Okay.
Okay. I'll see you tomorrow, guys, and we will do the test class coverage for a mock-up. Basically, we will do an integration project and we'll see the results. Okay?
Great. Thanks.
Thank you, guys.
Thank
Bye-bye.
you.
Thank you,
Good night.
Deepika. Bye.
Good night.
Good night.